G'day, folks. I thought I just might have a look at the situation with the DC to DC charger, which the application for that is that you're charging an auxiliary battery apart from your and from your cranking battery. So in most applications I see on the internet, they come out of the US and they're typically talking about charging a battery that's in a motorhome. Which is similar to I guess if you're in a four-wheel drive and you've got all your gear in the back of the four-wheel drive and you're camping, that's the same situation. So the auxiliary battery and the cranking battery are very close together. But it's a markedly different situation when you're towing a caravan behind a four-wheel drive or indeed a camper trailer. So I thought we might just have a look at that, because the issue is making sure you've got a suitable DC to DC charger. There's some limitations on some of them that you need to take into account to make sure that they will do the job that you want them to do. So our application, I think in Australia, we've got bigger caravans typically too, I suppose, certainly than English ones. And, the auxiliary battery is quite a long distance away from the source that's charging it, i.e. the starting battery. So let's have a bit of a look about how that works and the situation that exists and why there can be problems with some of these chargers.
Okay, here we've got a standard alternator four-wheel drive and about a 20-foot dual axle van. And typically with these vans, the wheels are well back, as illustrated in this diagram, and batteries are typically located above the axles to minimise any effect the weight has on, the ball weight in the van. So to try and make it even across the van. As I said, this is a standard alternator four-wheel drive, and you'll notice that the starting battery voltage typically is around 13.8 to 14 volts. And on that cable run in red, you'll see that the length of that is typically around over 10 metres. Let's just say over 10 metres. And in that, we've got a connector at the back of the car, typically an Anderson plug. And maybe worse, in some instances, these charging wires are run through the 12-pin or 7-pin trailer plug, which is completely inadequate for the amount of current that this thing's handling. So it should be an Anderson plug always. At the front, we've got a fuse. In this instance here, I'm talking about a 20-amp output charger at the caravan, so we've got a 60-amp fuse. There may also be, between the fuse and the battery, or just after the fuse, there may be a VSR, a voltage switch relay, which is enabled when the car's running and shuts down that circuit when the car's turned off. It's turned on by the nominal voltage of that front battery. So once it drops below 12.8, static lead-acid battery sits at around 12.5. So once it drops below 12.8, it disconnects that line through and stops that charger running, and that therefore stops your cranking battery being flattened.
All right, let's have a look at the difference between a smart alternator versus a fixed output alternator. So the alternator is the power supply for the vehicle for recovering the start battery after the engine started and provide power to the vehicle electrical consumer devices such as lights, air conditioning, radio, music and other devices that source their energy from the vehicle's electrical system or battery while the vehicle's running, and even when it's stopped, I suppose. There's two main types of alternators commonly used in today's vehicles: the traditional fixed voltage output alternator and a modern smart alternator. Fixed voltage alternators are far less common on new vehicles because the manufacturers are looking to reduce fuel consumption, and so their targets, are more stringent as far as emission outputs go, and so they're trying to reduce load on the engine, which increases petrol consumption or fuel consumption. A fixed voltage alternator has been the norm, but they can load up to 15%, I believe, onto 15% increase in fuel consumption onto an engine. So this is why there's been this move to smart alternators, and they work a little bit more cleverly by changing the charge output depending on what the vehicle's doing. So a fixed voltage alternator has always had a high enough voltage to successfully charge a secondary or auxiliary battery in the vehicle to a usable level for leisure or auxiliary use when it was mounted adjacent to or in close proximity of the starting battery. And typically that was a standard lead-acid battery in the past. The smart alternator system allows the vehicle to control the output voltage from the alternator based on the vehicle operating conditions to reduce electrical load and, in turn, mechanical load on the engine by the alternator. This renders it unsuccessful at charging a secondary battery system to a usable level. So here in this picture we can see I've got different points here to refer to in the blue letters. So let's have a look at this. A is the engine's not running, and you can see that the battery has relatively full open circuit voltage of the start battery is 12.6 volts. At B, the engine's been started. The alternator produces current to raise the system voltage, which you can see that going up from the 12.6 nominal starting voltage, racing up there towards the C location. Raise the system output voltage. Output current or amperage level will depend on alternator capacity, design, current, acceptance and engine speed at the time. Now at C, the alternator regulator will aim to hold the target voltage generally around 14.1. Whilst not a full charging voltage, this selected voltage will be appropriate for maintaining the start battery, and it's not excessive for long-term running at this voltage level. And at D, we can see the current will flow into the start battery to recover it from the engine starting consumption and run loads that are on at the time. And this current will decrease as the battery comes up in charge, recovering from the start discharge. Generally, this will occur within the first few minutes of runtime. So D, you can see that running down towards zero. And in this image here at E, the current will be regulated from the alternator to maintain the target voltage. So the alternator will try and maintain that voltage at 13.8 to 14.1 or something around about that. As you can see at the top there, it's maintaining a constant output voltage, and current will increase to make sure that the voltage stays up at that point. So the current is regulated from the alternator to maintain the target voltage and can increase and decrease as loads are switched on and off. Here I've just indicated at E that after a minute or so the DCDC Chargers cut in, and it's and assuming there's no other loads, it's just pumping out 25 amps to go to the DC to DC charger. Okay, so let's have a look at a smart alternator. So in this picture, we've got a graph similar to last time with the standard alternator. The top line's the alternator output voltage and the bottom line's current. At A, the voltage, so this is the engine, it's not running, and the battery has a relatively low open circuit voltage of around 12.4 on the start battery. As this system does not aim to achieve a full state of charge in the start battery. So typically, specific battery types are used for this application in order to achieve good performance and service life when operating at a partial charge for starter operation. So at B, the engine started, alternator produces output current to raise the system voltage, so it's charging the battery up, sticking amps into it, and the voltage level pops up to, as you can see, quite a high voltage at 14.8, something around about that, depending on the vehicle. And that current level will depend on alternator capacity, the system design, battery current acceptance, and engine speed at the time So typically here the engine's just been started and it's idling, I guess. So that's B. So the alternator at C has tried to achieve a target voltage generally upwards of 14.5 volts. So this is, belting in a bit of volts there at the beginning. At D, current will flow into the start battery to recover it from the engine starting consumption and run the loads that are on it at the time. This current will decrease as the battery comes up in charge. Generally, this will occur within the first few minutes again of runtime. The voltage will be decreased at this time when current flow into the start battery falls below a predetermined level, generally below 30 amps, meaning that the start battery is only partially charged, but it's well enough for repeated starting. So at E, the current will be regulated from the alternator to maintain the target voltage and increase and decrease as loads are switched on and off. The target voltage will change on factors such as temperature, electrical load, start battery, state of charge, and engine load. So there's a number of things influencing how the alternator performs at this point. Later on, as things change during acceleration and cruise, the target voltage will be low, around the open circuit voltage of the battery, as we can see there at 12.5 volts. So that's when you're accelerating, and that's to reduce load on the engine, and therefore it's more fuel efficient. So that's the reason they're doing that. And then later, during deceleration, the target voltage may be lifted to replenish any discharge of the start battery that may have occurred during acceleration and cruise. So this 12.5 volts could be maintained for quite a long time. While you're slowly going uphill, for example, or, when you're towing particularly, I guess, and your load on your engine's quite high, the alternator is not putting out a very high voltage. It's maintaining a fairly low voltage there. Now, this is important, and this is where issues begin with a smart alternator in particular for a caravan, and because of the distance away it is. So we've got here potentially this alternator only putting out 12.5 volts, or that's essentially what your battery voltage is sitting at. So that's where your source is, 12.5 volts on with a smart alternator as you're towing, as you're under load, going up hills, etc. It only brings that voltage up when you decelerate. And it's quite a bit lower, as you'll see from what the standard alternator is, which is sitting at around 13.8 to 14 volts, considerably higher running voltage. And that's there all the time on a standard alternator. By the way, smart alternators can be, in many instances on the cars, you can get that disabled to make them run as a normal standard alternator. You just ask the dealer. Not all of them will do it, or they charge you for it, some don't, but they can disable it and make it back to standard, and that's better for your battery. Anyway, that's a different issue. So that's the difference between these two, the smart alternator and the standard alternator. And that voltage difference is important. All right, so let's then go and have a look at what sort of DC to DC chargers do. Okay, so let's go back to this drawing of the four-wheel drive with a van and have a look at a smart alternator situation here. So as you can see, we've got the cranking battery at the front with a nominal voltage when the car's driving along at somewhere between 12.5 to 13 volts, as you saw from our graphs earlier. Initially kicking up to 14 point something, but then rapidly dropping off, and then under engine load, and particularly this is the case when you're towing, that voltage could be sitting somewhere around that 12.5 to 13 volts. Back down here in the caravan, we've got a battery at the back, an AGM or lithium battery. It needs 14.4 to 14.6, and that's why you need a DC to DC charger, because there's no way that front battery
and the alternator up the front, they don't care about this battery down the back. It's not in its immediate vision. It's off down the whoops there. It's 10, 12 metres away. So this line running down the back, regardless of the size wire you use, has got no chance of ever charging that battery without a DC to DC charger. Second reason you need a DC to DC charger is to charge the battery correctly, because it does have to come up to this voltage, and it has to hold that voltage for quite some period of time. And it has a proper charge profile for AGM and lithium batteries, and that maintains that battery correctly so that you get 100% out of it, because there's no way you're going to get that if you didn't have the DC to DC charger. So very important. All right. So the problem we've got here is this length of cable run. If you're pumping out to get 20 amps out of that charger down the back in the van, you need 25 to 28 amps at probably a minimum from the vehicle battery, or the alternator's got to be producing 25 amps just to run this charger. 25 to 28 amps. That's if you're maintaining the input voltage within the range of the DC to DC charger. So this is where it gets important about what this DC to DC charger is. Cheapy DC to DC chargers require a very high input voltage, up around, perhaps around 12, 13 volts. So it's not going to get that because of the losses in this cable run. This 10 or 12 metres of cable is going to, on a smart alternator, when you've got 12.5 to 13 volts up the front, can easily drop a volt or more down the back here. So this could be feeding this DC to DC charger with 11.5 volts, or possibly worse, depending, as I say, what size cable you're using there. Plus the losses in the Anderson connector, the fuse, a VSR, voltage switch relay up the front, all those various other points are potential voltage drops. It's not difficult for it to lose 1.5 volts under load. If you've got a 40 amp charger, that's worse. Second thing that happens is the draw on the front battery is going to be more than 25 amps. If the input voltage to the DC to DC charger is down at, as I said, you could possibly lose 1 volt or more, 11.5, 11 volts. This has to work a lot harder. Its efficiency gets far less, and consequently, to maintain that 14.4 to 14.6 based on an input of 11 or 11.5, it's working really hard. Therefore, it draws more current because it's less efficient. So you could be up over 30 amps you're pulling to produce 20 amps out of this charger at the rear. So that's an issue. So let's have a look at these chargers and see what's around on the market. Okay. So here's a view of, or a range of DC to DC chargers, and this is not all of them, but these are some of the ones that are on the market, fairly common. And so, as you can see, there's many and varied, and from good quality down to ordinary. So let's have a look at the specs on these. Okay, so here I've got a list of DC to DC chargers, many of which were in those pictures I just showed up. And I've highlighted here the DC to DC chargers that are of concern. And the reason they're of concern is because of the third column there, that input voltage minimum, right? Now, the highlighted ones all have high input voltages. And as we've discussed here, the voltage loss across the run from the cranking battery down to the back is an issue. Less of an issue if you've got a standard alternator, because that voltage is sitting up at 13.8 to 14 volts. You can afford to lose some volts. But let's look at this from the smart alternator perspective. As we were saying, they're sitting there a lot of the time, it's running at 12.5 to 13. This minimum input voltage becomes very important. And as you can see here, some of these are really high. The PowerTech, 13.2. The Moby is 13 volts. Hardcore's 12.5. A10 Power, 13 volts. Anything over, that's greater than 11 volts, I guess, is
is a concern. So of all of these, as you can see, the only ones that go down significantly lower, Victron, the iTech, the Renogy versions, and the Projector, kick-ass. But all these other ones, they require an input voltage not necessarily that far off what the smart alternator is running at when it's under load. As we stated, that engine under load could be sitting somewhere between 12.5 and 13 volts. We're going to lose a volt or maybe more from the cranking battery right through to the input to this thing. And that's, to some degree dependent on the size cable you use, but it's not hard to lose a volt with connectors as well. Got connectors and fuses there, all voltage drop points, as well as the cable loss itself. So this is important for a caravan and a camper trailer. That input voltage needs to be better than 10 volts, like lower than 10 volts, I reckon. Maybe the 10.8 is okay, but certainly that's about it. And all these other ones that are sitting up at 13 and 12.5, crazy. Okay, look, I hope that helps. I just thought I'd highlight this issue with caravans and camper trailers, and because I think it's been neglected in both UK and US. Certainly when you watch stuff, everything's based on the two batteries being relatively close proximity to one another, and that's quite different, I think, for the Australian experience with caravans, camper trailers, etc. So beware when you're buying, or if you already have a DC to DC charger, and you're finding that maybe it's not working as well as it should, and you've got a smart alternator, that you address that problem. As I say, you can get smart alternators, you can get the manufacturers or the service companies, Toyota, etc., Ford, they can disable that feature and bring your smart alternator to work as a normal standard alternator, which is much better for your battery, both your starting battery and your car, because it certainly does seem to affect battery life to some extent. If you don't charge those batteries up properly, that's not good for them. So it's a good idea to possibly get that disabled, and you'll have a better charging experience. But certainly if you've got a smart alternator and you're stuck with it running at low, at that sort of 12.5, 13 volts, be conscious about this input voltage issue, cable loss, connector losses, fuses, all these things causing voltage drops from your car down to your battery, and make sure, and I hope you can see from this also that with a smart alternator, it is imperative that you have a DC to DC charger. You can't, and I still see people who, not so much in caravans and camper trailers, but certainly in four-wheel drives, who don't have a DC to DC charger. And you should always have a DC to DC charger when you're running AGM or lithium-ion batteries, because they run at a higher voltage than the car's standard battery up the front. And clearly there's an issue. You're never going to charge up with 12.5 volts. You're never going to charge up your auxiliary batteries adequately. You may over a long time, but with this problem, particularly with towing, I guess, and the petrol conservation, fuel efficiency emphasis by the manufacturer to keep the load down on the engine. It's not the best thing for this application. All right. Anyway, hopefully that helps. See you later. Thanks for watching.